everybody, this is Mrs. Ellsworth, and what we're going to be talking about is a little bit more complex than the last session when we were talking about these binary ones where we would do the switcheroo and we would just have a simple crisscross or a switching method and we would come up with it. These are of two different atoms. Now we're going to be talking about ones that are a little bit larger. Okay, and let's go ahead and practice and remind ourselves what we do know. So iron, again, is Fe, and it's got a +3 charge because of the Roman numeral 3. Okay, and sulfide is the negative ion for sulfur. Okay, so it's a -2. Oops. And so we got an S and we got a -2. And so this 3 comes down over here. It does not go straight down, it comes down over here, so they're switching. And then this 2 will come down over here. And notice that there is no charges down here. This is telling you the number of the atoms. There are 2 irons and there are 2 sulfurs, and we're going to clean it up. And we'll hand in Fe2S3. Okay, and so that's the binary ones. This time we're going to be using polyatomic ions. So you need the purple polyatomic ion chart. And we'll go ahead and do these. So here again we've got iron again, iron 3, so that's Fe plus 3, and so that's great. But now you notice it's not sulfide, it's sulfite. So go look in that middle column on your purple polyatomic ion chart, and you're going to see this SO3, and it's got a -2 charge. Okay, so we're going to still do our switcheroo like we did before, but this time it comes down here, and you'll notice that this now looks like it's got 33 oxygens. So we're going to have to do something to clean that up, and so we'll put some parentheses around this to show that you've got 3 of this ion. Now the polyatomic ions are really closely packed ions, and that they behave like they're a single atom, just like we did up here. And so we just have to do a little bit of cleaning up to make sure that people understand what we've got. So let's rewrite this thing nice and neat. So it's Fe2, and it's got an SO3, and I'll have another 3 there. So it's still a 2-to-2 ratio. Okay, this one had a -2 charge just like sulfide does. It's got that 2-to-3 ratio just like what I had, but now it's got a polyatomic ion instead of just a single atom ion. And it's just treated exactly like we did before also. Okay, now there's another one real close to sulfite. So you got sulfide, sulfite, and sulfate. Okay, so go look in the middle column of that purple polyatomic ion chart. Okay, and so let's do this. So Fe has got a +3 charge, and sulfate is SO4, and it has got a -2 charge. Look at the top of that middle column, it says -2. Okay, so let's go and now do our switcheroo. So we've got 3 over here, we've got 2 over here. Okay, so now it's Fe2. Clean this up, Fe2 again, but now we've got SO4 that's got to be in parentheses so it cleans up. Otherwise it looks like you got 43 oxygens. No, we got to fix that. And you got 3 right here. Okay, so that's an introduction on what we're doing. Okay, so let's go and look at some more. We've got calcium sulfate next, and calcium is a +2. Okay, so calcium. Okay, and sulfate you saw again was in that middle column. That was the SO4, and it's a -2. Well, this is pretty cool. So when you look at this, you can see that your ratio that's coming down is going to be a 2 and a 2. Okay, so you know that these ones are going to reduce themselves. So it's going to end up being a 1. Let me get a different color here. A 1 and a 1. So we're just going to rewrite this thing as CaSO4. Now, this SO4 that's in here, it will never change what it is on your sheet. It will always remain SO4 in your formula no matter what your numbers are here. You don't do any adding or subtracting or anything. You do exactly what you did with the other ones, and you worry about these numbers coming down because they are your true ratios that you're dealing with here. So if you would change this and do some subtracting like this, it's something, it doesn't even exist. So just make sure that you're just moving the numbers and then reducing if necessary. So you would never reduce this, even if you would have a different one. Like there is one that's oxalate and it's a C2O4, and it's a polyatomic ion also. Even if you would have that one and you would have these twos coming down, nothing would switch here. You would never reduce these two. Even though one's a multiple of the other, you would never, because it would not be oxalate. Okay, so those polyatomic ions must always remain identical to what they are on the sheet. Now molybdenum, it is right here on the periodic table, and we got to have more information, so I got a Roman numeral in that problem. So it's MO, and then we got a 4 right here. Okay, and then nitrate is on your polyatomic ion chart. It's in the first column. It is a NO3, and it has a -1 charge. So we'll bring the 4 down here, the 1 down here. So we're going to clean it up, and it'll look like MO, and it's got a NO3 and then a 4 here. So do you notice that you only need to put parentheses here when it's got a 4 there or a 2? Anything greater than a 1, like this right here had a 1 on it, right? It had a 1 on it because we reduced it. You don't write it for a 1. And anything more than a 1, then you do need those parentheses, otherwise you're not showing the good ratios there. Let me get rid of that because that's just ugly. Okay, so here we go with this one. It's done. Now watch out. These are here capitals, so make sure that you're using your uppercase for these ones right here. Okay? Okay, ammonium acetate. Ammonium is the only positive polyatomic ion, and we briefly talked about it. It's NH4. It's in the very last column of your purple polyatomic ion chart. And what's its charge? It's a +1. Acetate. You can tell acetate is on your polyatomic ion chart too because it's got the 8 for the ending on it, just like these ones here. If it's got an ite on there, it is too. There are 2 of them that are cyanide and hydroxide that end in IDE. Otherwise, all the ones that end in IDE are on your periodic table. These ones all end in 8 and an ite. Okay, acetate. Let me get back on the track here. So it's C2H3. It's in the first column, and then an O2. And it has got a -1 charge. Okay, look at the top of the column of this. You'll see a charge is a -1. Okay, so this is so nice. You got a +1, -1. You don't have to do anything with it because it's a 1 and a 1, and we don't write 1, so it's just NH4, and then C3. Oh goodness, let me get that. H3O2, and it's done. You don't have to put parentheses around this because the number was a 1 right here. So, oopsie. There, I fix it. Anyway, so that's how you do the purple polyatomic ion charts. Now, I have one sheet that we're going to practice with in class, and then you can check your work, and then another sheet that you can hand in for credit. You have a great day. Bye-bye.